We often need to select subsets, columns and rows, of data frames. There are three methods to select rows and columns of a data frame. The first uses the loc property and is the most general. It can select individual elements, rows, columns, or blocks consisting of rows and columns. The second uses dictionary-like syntax and can be used to select one or more columns in a data frame or elements based on the index values of a series. The final uses .variable name to select a single column in a data frame or a single element from a series. Selection may reduce dimension so that selecting from a data frame can return a series or a scalar. Finally, pandas has special user-friendly features for selecting data from time series. Open Lesson 10 in VS Code. Before turning to the problems, we need to construct some data frames and series that we will use in this lesson. Let's start by importing NumPy and pandas using their canonical names. We then create x, y, and z. X uses a range, which we then reshape to be a 5x5 array. We can then construct the data frames. XDF is a plain data frame without any further metadata. XNamed is a data frame with an index, which we will fill in with a list, and some columns, which we also use a list to construct. YS is a plain series that contains Y. YNames is a series with the same index as XName. We can borrow the index to set it here. Finally, we can use print statements to show the values of all of these variables. Loc is used to select elements in a data frame using the metadata in the index or column names. Loc is not a function, and so uses square brackets. This syntax is similar to how items are selected in a list or values are retrieved from a dictionary. In a data frame, loc takes two arguments, rows and columns. Rows contains the element or elements that should be selected using the labels in the index. Cols contains the element or elements to select from the column names. Either can be a scalar value or a list of values. The trivial slice, a colon, is used to select all elements in a dimension. When selecting only rows, it is not necessary to explicitly supply the trivial slice, and the final two lines, loc row colon and loc row, are identical. We can use loc to select rows and columns by name. Rows are in the first position, so XNamed loc R1 will select the second row of the data frame. Next, we need to select the second column. There are two ways to get this column. We can use loc, which needs to use the colon, a generic slice, to select all rows, and then use C1 as the column. Entire columns are selected from data frames using dictionary-like syntax. This method of selection omits the loc operator and directly selects from the data frame. Multiple columns can be selected using a list of column names. This is equivalent to using loc with the trivial slice in the row's position and the list in the col's position. In a series, the dictionary syntax selects elements using the labels in the index. The second method uses the dictionary-like features of a data frame. The columns are the keys, so that xNamed bracket C1 selects column C1. Finally, we can use xNamed.C1 to select this column as well. When selecting a single element, either using loc, dictionary syntax, or .variable syntax, the dimension of the value returned is reduced. This is known as single value selection or scalar selection. Using single value selection in a data frame produces a series if selecting in only one of the dimensions. If selecting in both, the value returned is a scalar. In a series, single value selection always produces a scalar. The next problem asks us to select the second element of yName. Series are also dictionary-like, except that the key is in the index. We can use this feature to select R1 directly. Alternatively, we can also select R1 using loc. Series support dot selection if the variable name is a valid Python variable name. R1 is a valid Python variable name, and so this method can be used as an alternative. The multiplicity of methods available to select can be a bit confusing. I prefer to use loc in my own code, since I feel it makes it most obvious to tell whether I'm selecting rows, columns, or rows and columns. Using multiple selection through lists of index values or column names preserves the dimension of the value returned from the selection. All three of these examples of selection in a data frame produce a data frame. Mixing multiple selection and single value selection reduces the dimension, since the single value selection is always dimension reducing. The sample here selects 2 rows in a single column, and so the series returned has 2 elements. Wrapping a single value in a list selects a single element while preserving the dimension. In the final example, the new data frame contains a single column from the old, but is not reduced to a series. Multiple selection by column name uses lists of elements to select. Here we select a block using loc with a list of row names, R1 and R3, and a list of column names, C0 and C2. These select the correct rows and columns. Note that we can mix dictionary-like syntax and loc. We could do this in either order. Here, I will use the dictionary first and then the loc to get the rows. We can run the cell using only the dictionary selection, which returns 2 columns. Then, I can add the loc for the row selection. Next, I will use the loc to get the rows, and then the dictionary to get the columns from the selected rows. Here we see loc has selected 2 rows. The dictionary selection then selects the columns. Mixing selection like this is not recommended, and loc is the preferred method for selecting rows and columns in a data frame. We are asked to repeat an earlier problem on the data frame with the default index and columns. These are just integers starting from 0. Selection is no different, So we can use loc with two lists, one for the rows containing 1 and 3, and one for the columns containing 0 and 2. Moving on, we're going to look at series selection with the default index. We can select using either the dictionary syntax, which is ys bracket 4, or using loc, which uses ys.loc4. There is no important difference here relative to using named indices or columns, since we are simply substituting an integer for a string. Next, we are asked to select a subseries from a series. We can use a list containing the index entries with either dictionary syntax or with loc. Here, I will use the dictionary syntax. Next, I repeat the selection using loc and the list R0, R2, R4. Next, I use loc to select in ys, which has the default index. When a DataFrame or series has a date-time index, which requires that the values in the index are dates that are sorted, then a special syntax can be used in selection. Values can be selected by date, month, or year using different levels of specificity. The three examples here select all values on December 31st, 1999, in December 1999, and in 1999, respectively. Dates can also be selected in a range using the slice operator between any two date selectors. This selection selects all values between December 31st, 1999 and December 31st, 2000, inclusive. The inclusivity of the endpoint differs from other slice selectors, and so some caution is needed if the end date should not be in the sample. We will use the momentum return data to examine selection by date. The first problem asks for the data on a single day. We get this using loc and the string date 2016-2-16. The next problem asks us for data in March of 2016. This selection is nearly identical, except that we do not use a day in the string, so 2016-3. We are then asked to select everything in 2016. Here we can leave off the month and the day to get the data in a specific year. Using .loc 2016 selects the correct data. Finally, we are asked to select the data in a specific range. Here we can use a slice where start and end are string dates. We use 2016-5-1 as the start, and 2016-6-15 as the end. Note that this type of slice includes the endpoint. This is different from standard slices and is a quirk of slicing a date-time index. Loc allows elements to be selected from data frames and series using the metadata values contained in the index and the column names. My preference is to always use loc when selecting these values. It is also possible to use dictionary syntax, which bypasses loc when selecting columns only in a data frame. The shape of the object returned depends on the values used to select. Single value selection reduces dimension, so that the value returned from a selection on a data frame is either a series or a scalar, and the value returned from a series is always a scalar. Time series expose special syntax for selection in the time dimension using strings. These can be days, months, or entire years. It is also possible to select a range of dates, although care is needed since the endpoint is included in this selection. This is a different behavior from standard slice selection on Python objects, which do not include the endpoint.